Tamil? I need your feedback. So
Sir, both.
Both. Okay, very good. Okay, let me present my screen. Someone can inform me whether it is visible to you or not. Whether my screen is visible to you all?
Yes, sir.
Good. So this is the syllabus that you are going to study, the subjects, the syllabus for TDFM. So first our code is the 18MET46. Okay, so the code you must remember, and the thermodynamics and the fluid mechanics. Okay, this is the subjects. So you people are so lucky to study the both thermodynamics and fluid mechanics in a single unit. So as a mechanical engineer, we need to study thermodynamics as a separate subjects and fluid mechanics as a separate subjects. I think you people are so lucky to have the two subjects in one. Okay, so this is the thermodynamics and fluid mechanics syllabus. Okay, and another thing, this before studying this thermodynamics and fluid mechanics, you might have been studied or you have been studied the laws of thermodynamics in the 12th standard and different types of boilers, compressor, refrigeration in introduction to engineering. Am I correct? Have you studied or have you heard about this word in the previous classes? Have you ever heard about these words in your previous classes?
Yes, sir.
Okay. So this syllabus consists of 5 units. The unit 1, the heading is the laws of thermodynamics. This is fully a problem-oriented unit. Very simple unit. This unit is very simple unit, and it consists of problem. Okay, the problem alone we are going to see in the first unit. Okay, and the second unit is the formation of boilers. Okay, the formation of steam in the boiler, how the steam is formed, and based on the pressure and the temperature, how the steam property will be varying. Okay, and boiler or the steam conditions we are studying, and different types of boiler, what are the components that are installed and that are used in the boiler will be studied in the second unit. And the third one is the compressor. Okay, in the compressor we have two types of compressor: positive displacement compressor and negative displacement compressor, and different classification of the compressor and reciprocating compressor, and the energy conservation, how the energy is conserved in the compressor. So these are the various topics that we are going to see in the third unit. And the fourth unit is the refrigeration. Okay, very interesting topic. Since we are using air conditioning and refrigerator in our home, we need to study as an engineer. We need to study the working principle of refrigeration. That is, it comes that the term refrigeration comes for both the air conditioning as well as the refrigerator. Okay, so as an engineer, we should know what are the basic failure of refrigeration. Okay, so we need to identify the problem. Okay, and the final unit is the fluid machineries. We are going to deal with the pump, turbine, and various components. Okay, so these are the various topics that we are going to study in the thermodynamics and the fluid mechanics. So in this case, you are only fluid mechanics, only fifth unit is comes under the fluid mechanics. Remaining all the 4 unit it comes under thermodynamics. Okay, or thermal engineering. Okay, so the book we have listed here is the R.K. Rajput book, Thermal Engineering, Lakshmi Publications. The soft copy of the book is available. Meanwhile, I will be uploading in the Google Classroom, so you can download it and you can use it. You can use it for writing assignments or writing some other homework. Okay, so you can make use of it, and these both books are available. Okay, so I will be uploading it very soon. Okay, so this is the syllabus. So do you want to ask anything regarding this syllabus? This is the 3 credit course. Once you get pass in the subjects, you will be getting a 3 credit. Okay. So if you want to raise any questions, please ask questions. Any questions?
No, sir.
ஒரே ஒருத்தங்க தான் ஆன்சர் பண்றாங்க இல்லையா? Hello, are you people there?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, shall we start?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Okay. So in the first topic, we are going to see about the system. Okay. So what do you mean by this thermodynamics? Let us start our topic in general. So what do you mean by thermodynamics? Tell me, any idea? Raja, this is not an என்னன்னு சொல்றது ரொம்ப ஸ்ட்ரிக்ட்டா அவங்கள இது பண்றது மாதிரி இல்ல. So we need communication from both the side. ரெண்டு பேரும் பேசணும். ஓகேங்களா? So then only we can able to understand. Okay. So please tell me, what do you mean by thermodynamics? தப்பா இருந்தாலும் பரவாயில்ல சொல்லுங்க.
Studying of heat in motion, sir.
என்னமா சொல்லுங்க? Heat.
So study of heat in motion, sir.
Very good, very good, very good, very good. That is the term. Okay, the study of heat in motion. Exactly. You see here, the thermodynamics relates. The thermodynamics come from the Greek word thermi. The thermi means heat, and dynamics means power. That is the study of heat which is in motion. Okay, that is called as thermodynamics. Okay, so these thermodynamic subjects is applicable or used in different areas or different sectors. What are the various sectors? That is the power generation sector. So can you put out an example for the power generating industry or the power generating unit? Tell me. Or power generating plant? Put out one example for the power generating plant. Any idea?
Sir, nuclear power.
Not only nuclear power, any types of power plant, power producing unit. Okay, power producing unit is called as the power plant. It consists of thermal power plant, okay, nuclear power plant, diesel power plant, gas turbine power plant. So the power generation unit. So whenever a power is generated, the thermodynamics comes in major play. Okay, and the refrigeration sector. Okay, what are the various components involved in the refrigeration? What are the various components comes under this? Refrigeration la enna porum?
Condenser,
compressor.
evaporator.
நான் கம்ப்ரஸரோட இது கேட்கல, காம்பனன்ட்ஸ் கேட்கலப்பா. ரெஃப்ரிஜரேஷன்ல ரெண்டு மேஜர் டிவைசஸ் இருக்கு. வாட் ஆர் த டூ டிவைசஸ்? One is the air conditioning system and another one is the refrigerator system. இல்லையா? ஃப்ரிட்ஜும் ஏர் கண்டிஷனிங்கும். ஓகே, now thermodynamics is the subject that is involved in the human body, air conditioning system, car radiators, power plant, refrigeration system, and in airplanes. Okay, so these are the various applications where the thermodynamics subjects is widely used. Okay, so regarding the fluid mechanics, tell me which fluid mechanics subjects padicha, what are the technical area we can work it? The same, the power generating unit. Power generating unit like turbine in our. So which power plant uses turbine? Which power plant uses turbine?
Sir, hydropower plant.
Anybody? Tell me.
Sir,
So the hydroelectric power plant,
steam.
Wind.
steam turbine power plant,
Sir, wind.
wind turbine, very good. Any other power plant that we use turbine? Gas turbine. Okay, so that is also used for power generation. Okay, so let us see our first topic, that is the microscopic approach and the macroscopic approach. Yeah, the study of or first let us see about the system and the surroundings. Okay, if the two technical terms called the system and the surroundings is very necessary. Ipa nama the entire thermal engineering syllabus I have shown, right? So it comes under the book RK Rajput ஒரு book. Okay, இந்த book என்னன்னு சொல்றோம்னா it is called as a system. Okay, so in this system, by the Rajput book, we can study the thermal engineering subject. Am I correct? Am I correct?
Yes, sir.
So the object or a system or what can we call it as a quantity of matter or a region in space or something which we have taken for study is called as system. So இப்போ இதுல நம்ம ஒரு turbine எடுக்கிறோம். Okay, so we are taking a turbine. So this turbine, this portion is called as the system. Okay, system na enna a quantity or a region that we are going to study, that is called as the system. Okay, the quantity of matter or region in space that is chosen for study. நம்ம எதை பத்தி படிக்க போறோமோ அதுதான் நம்மளோட system. And the next term called the surroundings. So the system and the surroundings are separated by a boundary. Okay, the thermal engineering subjects நம்ம இந்த புக் மூலமா மட்டும் படிக்க முடியாது இல்லையா? Something we can see or we can get the information from the internet or the data source from other data source. Okay, that is called as the surroundings. Okay, that is called as the surroundings. So that is called as the surroundings. So what do you mean by the system? Tell me. What do you mean by the system? What do you mean by system? A system is something or a region in space that is chosen for study. Okay, system grade region of space or matter chosen for study. Okay, understood? Have you understood?
Yes, sir. Understood.
Okay, நம்ம எதை பத்தி படிக்க போறோம்ங்கிறது தான் சிஸ்டம். ஓகே, நம்ம சிஸ்டத்தை தாண்டி நம்ம வெளியே படிக்க போறது என்னது சரௌண்டிங்ஸ். ஓகே, so the system and surroundings is separated by a layer that is called as boundary. Okay, the system and the surroundings are separated by a layer that is called as the boundary. Okay, understood? Now we can see that the system is the quantity of matter or region in space chosen for study, and the surrounding is the mass or region outside the system, and the boundary it consists of two types of boundary. Okay, we have an imaginary boundary as well as the real boundary. Okay, so this is the system and the surroundings. A problem or system. Now we can go for this system. So I think this is the system. Okay, in the system we are going to study. Okay, the study of the basic components in a bigger size. Bigger size approach is called as the macroscopic approach. Okay, so I think I can put out a small example. We are என்னன்னு சொல்றது, ஓகே, நம்ம உடம்புல பிளட் இருக்கு இல்லையா, பிளட். ஓகே, ஸோ பிளட் நம்ம வெளியே எடுத்து பார்க்குறோம். ஸோ பிளட் வெளியே எடுத்து பார்க்கும்போது somehow it will be in dark red or pale red or orange red. ஓகே, blood of the color வந்து blood-ஓட கலர் வந்து it will be vary. It depends on the human body. ஓகே, ஸோ அந்த பிளட் என்ன கலர், எவ்வளவு வெளியே வந்திருக்கு, எவ்வளவு குவான்டிட்டி வெளியே நம்ம எடுத்திருக்கிறோம். ஓகே, ஸோ that will be considered as a macroscopic approach. ஓகே, இப்போ இதுல சிஸ்டம் என்னது, இப்போ நான் சொல்ற எக்ஸாம்பிள்ல சிஸ்டம் என்னது, ஹலோ
சார் blood.
சிஸ்டம்ங்கிறது வந்து blood. ஓகே, அதுல the study of the system in a bigger size approach, that is the size of the blood, the quantity of blood that we have obtained, the color of the blood that we have obtained. Okay, and viscosity of the blood. இது எல்லாம் டீடைல்டா வெளியோட்டமாக மேலோட்டமாக ஸ்டடி பண்றது, அதுதான் அப்ரோச், மேக்ரோஸ்கோபிக் அப்ரோச். மேக்ரோஸ்கோபிக் அப்ரோச் in the sense we are studying in the மேலோட்டமான ஒரு அப்ரோச், மேலோட்டமான ஸ்டடி. ஓகே, தட் இஸ் கால்ட் அஸ் பிக்கர் சைஸ் அப்ரோச். இது வந்து எப்படி சொல்லணும்னா, ஒரு மீடியம் கிரேட்ல இருக்கிற பையன் மேலோட்டமா ஒரு 3 கொஸ்டின் 4 கொஸ்டின் படிச்சுட்டு போனா பாஸ் ஆயிடுவான் இல்லையா. அதே இது நல்லா படிக்கிறவங்க என்ன பண்ணுவாங்கன்னா, they will cover each and every line in the book. That is called as the microscopic approach. And same the system, blood system எடுத்து நம்ம என்ன பண்றோம்னா, the studying of the interior, what are present inside the blood, what are the particles that will be present in the blood, that is hemoglobin content, RBC, WBC, அதுல எவ்வளவு அயன் கண்டென்ட் எல்லாமே நம்ம மைக்ரோஸ்கோபிக் மூலமா நம்ம அப்ரோச் ஸ்டடி பண்ணுவோம் இல்லையா. ஸோ ஈச் அண்ட் எவ்ரி பார்ட்டிகிள்ஸ் ஆர் ஸ்டடிட் யூசிங் microscope in nature. Okay, microscopic size, that is called as the microscopic approach. Okay, have you understood this term? Have you understood this term?
Yes, sir.
Macroscopic and microscopic. அதே மாதிரி thermodynamics is classified into two types. One is the classical thermodynamics and another one is the statistical thermodynamics. So the classical thermodynamics only we are going to study. So the classical thermodynamics comes for macroscopic approach, and the statistical approach is done for this microscopic approach. Okay, so I think can anyone tell me what do you mean by this macroscopic approach and microscopic approach? Tell me. Anyone? Any volunteers? Or shall I call out the name? Balasubramani.
Yes, sir.
கொஞ்சம் சொல்லுங்க பார்க்கலாம்.
சார் என்ன சார் மைக்ரோஸ்கோபிக்னா மேக்ரோஸ்கோபிக் ரெண்டு டிஃபரன்ஸ்
ஆமா ஆமா ஆமா.
சார் மைக்ரோஸ்கோபிக்னா இது டீப்பா அந்த சிலபஸ் ஃபுல்லா படிச்சுட்டு போறது சார். மேக்ரோஸ்கோபிக்னா அப்படியே மேலோட்டமா பார்த்துட்டு போறது.
அதேதான்.
சார்.
ஓகே, குட் குட் குட். சரி, ஓகே, குட். அரவிந்த்.
சார்.
So what do you mean by a system? சிஸ்டத்துக்கு வேற ஏதாவது ஒரு எக்ஸாம்பிள் சொல்லேன். யூ கேன் புட் அவுட் சம் எக்ஸாம்பிள் ஃபார் ஏ சிஸ்டம். ஏதாச்சும் ஒரு சிஸ்டம். எனி ஏதாவது சொல்லு. கண்ணில் படுற சிஸ்டம் ஏதாவது சொல்லு.
சார் ரீஜன் ஆஃப் ஸ்பேஸ்.
எக்ஸாம்பிள் சொல்லு.
Cricket ground.
Cricket ground. Okay. Mobile phone is the system. Laptop is the system. Okay. Book is a system. TV is the system. Ellame something what we are going to study is called as the system. Okay. Cricket ground la we have a boundary. Illiya, or outer la we are having a boundary. Okay, so that boundary line irukum. So that is called as the boundary. Okay, boundary ki veliye pochina, that is the surroundings. Okay, adhe madri mobile phone. The mobile phone that we are going to study is the system. Okay, so mobile ki veliye thandi pochina, that is the surroundings. Okay, I think everyone can understand this concept. So may I continue with the next topic?
Yes, sir.
புரிஞ்சுதா? Okay, good. Then the next topic. So how can we store energy? Energy நம்ம ஸ்டோர் பண்ணி வைக்க முடியுமாப்பா? எனர்ஜியை நம்ம கிரியேட் பண்ண முடியுமா? What is the law of conservation of mass? What is the law of conservation of energy? I think you have been studied in the...
we cannot create or destroy.
Yeah. So the energy cannot be created nor destroyed, but it can be transformed from one form to another form. Okay, so that is the general law. Okay, see, you are seeing a sumo player. He is having a punch. Okay, he is having a punch on his face in 5 unit. மூஞ்சில ஓங்கி குத்துறாங்க 5 unit of punch. Okay, so that punch cannot be stored inside his body. Either he should move towards the back side, or some portion will be stored inside his body. Okay, see, I am punching the sumo player face with 5 units, and the 4 unit will be coming out in the direction of in which I am punching on his face. Okay, he is moving to a certain distance. In that distance, he is releasing 4 units, and remaining 1 unit is stored inside the body. Okay, and this is the basic principle. Okay, now let us consider this as an example. Okay, this is the turbine. Okay, we are giving 90% steam. It is coupled with the generator, and the steam is coming out. So can we expect the same 90% steam in this turbine? இது வந்து inlet. இது வந்து outlet. Can we get the same 90% steam in the outlet?
No, sir.
No. Okay. Similarly, I am placing a vessel which is filled with water. Okay, I am pouring 1 liter of water and I am making the vessel to heat. Okay, after 10 minutes, will the vessel has the same quantity of water?
No, sir.
No, sir.
Why? What is happening there?
Transfer, sir.
evaporation.
In form of heat.
So the energy, you cannot, evaporation, you cannot say that. You can point out generally. So the energy is transformed from one form to another. Okay. So in this turbine also, if we are giving a 90% steam input for this turbine, we cannot expect this 90%. So we will be expecting the 70% in the outlet condition and the remaining 25% will be the losses, or it comes through the generator, or it comes to the generator loss or turbine losses. Okay, understood? Next important topic is the kinetic energy and the potential energy. So tell me, what do you mean by this kinetic energy and potential energy? What do you mean by kinetic energy and potential energy?
Resting energy is potential energy.
Okay, illama. What do you mean by kinetic energy? So the kinetic energy, physics you might have been studied. Ke is equal to half mv square. See here, I am placing a stone, okay, at the top of this area, okay, in which the potential energy formula is mgh. Okay, so the mass, gravity and the accelerations both will be acting. Okay, see here, the mass of the stone, gravity of the material, gravity, acceleration due to gravity and the height. So all these relevant to the potential energy. And when we see this area, we can see the kinetic energy is 0, because the kinetic energy here, the velocity v is, it is in standstill. Okay, the stone is in standstill. Okay, so the kinetic energy is always 0. Something that it will be moving is called as the kinetic energy. So kinetic energy is move or that is the mass into velocity. See here, the stone is falling at the ground and we can see the 3 unit of the, from the 10 unit of P, it is reaching 7. Okay, and K is 3. So once it touches the ground, you tell me what is the value of P and what is the value of K.
Ke will be 0.
Ke
0.
0. What is Pe?
Maximum.
எவ்வளவு வரும்? எவ்வளவு வரும்? What is the value of
Must have some value.
see, listen, the stone inga விழுது. Okay, Pe and Ke. Ke inga வரும்போது it will be 0, whereas Pe is also 0. How? என்ன ஆகுதுன்னா, the formula for potential energy is mgh. The height is 0. If the height is 0 இருந்துச்சுன்னா வரும், இப்போ மாஸ் வந்து 5 kg of stone, 9.81 into acceleration due to gravity வந்து 0 இருந்துச்சுன்னா the entire time will be 0. So the height plays an important role in the potential energy. That is given by the formula mgh. Okay, and kinetic energy ki, the fluid or the particles that should be in moving direction, movement avano. So that is called as the kinetic energy. So the kinetic energy is represented by half mv square. Okay, understood?
Yes, sir.
Okay. Then move on. Then we move on to the next topic. Okay. So the boundary, as we have seen that we have several types of boundary. One is the moving boundary, and another one is fixed boundary. Okay. So this is the most widely used boundary. Moving boundary ஆவும் இருக்கலாம். இது வந்து இந்த இடத்துல இருந்து இந்த இடத்துக்கு மூவ்மெண்ட் ஆகலாம். Okay. Or it can be fixed. So I will be pointing out a small example for this boundary. We have two types of system. Okay, a system or a region of space, that's something we are going to study, is called as the system. Okay, now we have two types of system. One is the closed system and another one is the open system. So have you, in your day-to-day life, you are mostly using the closed system. Okay, so what do you mean by the closed system? Any idea? In the earlier classes, you might have been played with the syringe. Syringe which விளையாடிருக்கீங்களாப்பா? Syringe.
Yes, sir.
Yes, sir.
என்ன பண்ணிருப்பீங்கன்னா சிரிஞ்ச் எடுத்து நீங்க ஜக்குல வாட்டரை நீங்க எடுப்பீங்க இல்லையா? Am I correct? So once you fill it completely, once you அதுல வந்து முக்கிட்டு நீங்க திரும்ப அதை இன்சைட் அந்த பிளஞ்சரை நீங்க எடுக்கும்போது வந்து பாத்தீங்கன்னா water will be moving upward இல்லையா? So is there any possibility to add water further? அதுல என்ன quantity of water எடுக்க முடியுமோ that quantity of water will be alone taken இல்லையா? Am I correct?
Yes, sir. Yes, sir.
So once we have to add further water, நம்ம என்ன பண்ணி இருக்கிற water நம்ம push பண்ணி வச்சிட்டு திரும்ப we have to take the water. Okay, so that is the closed system. Okay, with the moving boundary. Okay, and the closed system அதுல 5 ml எடுக்கலாம், 2 ml எடுக்கலாம், 1 ml எடுக்கலாம். So the syringe will be in moving direction. Okay, இதுதான், let us consider this as a syringe. So we can take the water, or இங்க வந்து நீங்க water fill up பண்ணிக்கோங்க. Okay, either it will be in x value. See here, there is a change in x. Either we can take 2 ml, here we can take 5 ml. So it is called as a closed system with the moving boundary. Understood? Understood? புரியுதா?
Yes, sir.
பாவ ஹேமா மட்டும்தான் ஆன்சர் பண்றாங்க. What about others? போர் அடிக்குதா? Is it boring?